Alright, we are finally getting to that wonderful deductive reasoning. So what you need out today is your workbook. We're going to be taking notes on pages 25 to 28-ish. And you'll also need one other sheet of notebook paper as well as something to write with. So if you don't have those materials, go ahead and pause the video and restart when you have them. Alright, so today we are talking about deductive reasoning. Think about along the lines of Sherlock Holmes. Sir Arthur Conan Doyle wrote those books, and they've been portrayed in all kinds of new movies and everything like that. So I know you guys are familiar with it. Alright, so deductive reasoning, it says here, connects true statements to form a valid conclusion. Basically what's happening here is we could say, if it is raining, then I need my umbrella. If I need my umbrella, then I need to go to my car. If I need to go to my car, then I got to get permission from the front office. So we can connect all of those statements by saying, if it's raining, I need to go to the front office. You ever have one of those friends that they have a train of thought, okay, and they say something, and then 5 seconds later they say something else, and you're like, how did you get from A to F? And they were like, well, B, C, D, D. You know what I'm saying? Like, it sounds like they're not making any sense and they're just jumping around, but they actually had a fluid train of thought. We're going to be connecting these flows of thoughts, if you would, with deductive reasoning. So what we're going to do here, and this is a very visual representation of deductive reasoning and the thought process that we're going to use when we prove things. Okay, so it says, given M, prove C. So given that I know M is true, I need to prove C. Alright, so M implies T. Okay, well if M is true, that means T is true, so take a look. Alright, over here it says, well if T is true, then B is true. Well if B is true, then K is true. If K is true, then C is true. So there you go. That's how you connect the thoughts between M to C. Your deductive reasoning. Alright, so I want you to try this one, pause it, and come back. Alright, so what you see here is my work. Okay, in order to prove Z true, okay, you can work your way backwards. We need to know that both Q and B are true. Okay, we are given that both C and D are true, so I start with D. D implies T, T implies B. Well, I have 1/2 of the Q and B that I need. Alright, here it says C. C implies W, W implies Q, and Q over here. So now that I have proved the connection between C and Q and D and B, I know that Q and B are true, therefore Z must be true. Notice I did not use this box way over here. K implies N. We didn't need it. Okay, it was there to just kind of throw you for a loop. Alright, so question number 1 in your reflection says, write a symbolic notation for the chain of reasoning in each part that proves. So I need to go, so we're looking at our last example, part B. Okay. Oh, excuse me. We're actually looking at part A. So the first example, part A, that we did, we started out that we were given M, and we had to get all the way to Z. So we know that, or excuse me, C. So that M implies T, implies B, implies K, implies C. So what we can say, so M implies C. And then for part B, we had a couple things that we needed to do, so we might need a little bit more room here. First off, we said that C implies W implies Q. Alright, and then we had D implies T implies B. We know here that Q and B imply Z. So what we can say is that C and D imply Z. Alright, so in this chain of reasoning, what do you call the statements that have arrows only pointing away from them? Okay, those would be our hypothesis. So the ones that are being pointed toward is my conclusion. So hypothesis has the arrow pointing away from them, and the conclusion is the one that has the arrow pointing toward them. Alright, so are there any statements in part B not used in the chain of reasoning? Well, yes. There was, and it was K implies N. We had nothing to connect. We did not know that K was true. We did not say C implies K. Okay, if we can't imply K, then we can't use K implies something else. Alright, so in the space below, we're going to draw basically what is called a flow chart. Okay, so I want you to pause it and give it a shot. Basically what you're doing though, you have C and you have D. Draw a connection from here all the way down to Z. Okay? Alright, so as you can see here, I've connected C and D to Z. So C implies W implies Q, okay, which is here, Q and B. And then D implies T implies B, which is here, Q and B. And now that I have both Q and B, I can say that Z is true. Alright, now here is our next example, number 2. Draw arrows to show the logical reasoning to prove the statement. Okay, we are going to have to actually provide some missing information. What do I need to know so that this connection is fluid and makes sense? So we're given K, so we're going to start here with K, and we need to prove B, so we got to get over here somehow. So if I know K implies D, well then I see a D here, D implies W, W implies R, R implies N, okay, N implies A. Well, I don't see an A anywhere. That means that the missing piece of information is A. So here we go. N implies A implies M implies B, and therefore we have landed in the final spot. Winner, winner, chicken dinner, right? Okay, let's answer some reflection questions regarding this. It says, write the symbolic statement of your chain and reasoning in example number 2 proves. Well, we can say that K implies B because we have shown that K to all those different letters comes back to B. Is there more than one way to complete the chain of reasoning in example number 2? Okay, I have a question for you. What if instead of putting an A here, okay, we could put something else? What if we put K in the box? Okay, so instead of putting A in the box, we would put K. So let's erase this and see what it would look like. Bloop. Alright, so instead of having A here, we could put K. And now all of a sudden, we don't need this arrow. We could say K implies M, M implies B, and there we are, back to go. So we actually would save ourselves a lot of step if we just put K in the box. So going back to this slide, fill in that into. Alright, in example 2, suppose that the box with missing information is completely and entirely blank. Could we then replace that box? So we have here K implies M. Let's say that the whole box is blank. Well, could you kind of just cheat a little bit and put K implies B and be done with it? So if we put K implies B in the box, we're done. Easy peasy, right? You would just say K implies B, that box, which it would then imply B, and then you'd be done with it. Okay? So make sure you have these all written down for me. Alright, now some other things that you need to be aware of for deductive reasoning. The first of that is the law of detachment. We know that P implies Q as a conditional statement. Okay, so if that statement is all true, then P is true and Q is true. Okay, in order for the whole statement to be true, P and Q have to be true. Now the law of syllogism, I know that's a fun word to say, right? Syllogism. It says if P implies Q and Q implies R, then P implies R. So this is the reasoning we've been using in our previous, the logical boxes where we were connecting the statements. Basically, we would just overpass the middleman. Okay, instead of saying, if it's raining, then I need my umbrella. If I need my umbrella, I need to go to my car. You could say, if it's raining, I need to go to my car. That's what we call the law of syllogism. Alright, so taking a look here, it says, use the true statements to determine whether this conclusion is true or false. So first things first, we have a lot of information. Let's take it one at a time. It says, if it looks like rain, then I will bring my umbrella to school with me. So we're continuing on with the rain theme here. Alright, cool. If the clouds are in the sky and the sky is dark, then it looks like rain. If I bring my umbrella to school with me, then I will hang it in my classroom closet. This morning, there are clouds in the sky and the sky is dark. So this right here, there are clouds in the sky and the sky is dark, is my first statement. I am given this statement. Notice it doesn't start with if. That's kind of your hint as to look. Alright, and so we need to work our way from the fact that today is cloudy and the sky is dark to the conclusion that my umbrella is hanging in the classroom closet. So this morning there are clouds in the sky and the sky is dark. Well, I can see that if there are clouds in the sky, then it looks like rain. So that means that A implies B, and B means it looks like rain. So if it looks like rain, so we have B implies C, then I will bring my umbrella to school with me. So that right there would be statement C. And then if I bring my umbrella to school with me, C implies I will hang it in the classroom closet. So we have that A implies B implies C implies D, and my conclusion is D. So this is a true statement. Since there are clouds in the sky and the sky is dark, this is going to be a true statement. It means I have to have my umbrella in that classroom closet based on the following information. Okay? So this one might need to go on your separate sheet of paper. I should have mentioned that at the beginning of this. Okay, so this probably is not in your workbook. You just need to put it on a separate sheet of paper. Alright, and then our last example for today is this one. It says, use the truth statements to determine whether the conclusion is true or false. If so, explain your reasoning. So automatically I'm going to take a look at this list, and I notice that the only one that doesn't start with if is the blender is dirty. So that is my starting conclusion, or starting hypothesis, and we need to get to the conclusion that Pete needs to clean the blender. Alright, so if Pete is thirsty, he'll drink a milkshake. If he wants to drink a milkshake, he'll need to use the blender. If he needs to use the blender, he needs to clean it first. So I'm given that the blender is dirty and that he needs to clean it. Well, I don't see if the blender is dirty anywhere. Which means that there's no way that I can connect this. Maybe Pete does need to clean it if it's dirty. I don't know. Maybe he does. But based on our information, we can't draw any conclusions. So you're going to say no conclusion. Oops. Can be drawn based on the above information. So we're going to have to label this as false. Based on the information I have, this conclusion is false. Alright folks, that's all we have for today. That is deductive reasoning. I will see you tomorrow.